Hello everyone, Shubhankar here, and here I am displaying to you a project I made for a turner selection criteria. So let's get started. So I chose to build a real-time data aggregation service. What this project does is it fetches data from two or more APIs and merges the results of a single coin and displays them in a centralized manner. So it can be used to display a front end of any coin comparing website or crypto website, anything for like that matter. So this is the key features of this application, and basically we get started from fetching the data, which is the fetch data file. I am fetching the data from two APIs. One is the DexScreener API, and one is the CoinGecko Solana API. And the next part, what I'm going to do is we are going to check this properties, any two properties which are common to any APIs. We are going to take that properties and we are going to display them in a singular manner. And to really aggregate the functions, first we need to check if these properties even match or not. So before that, I'm going to be checking if the Redis has the properties or not in the form of cache data. If it does, we'll be obviously passing it and returning it. If not, it will do parallel processing of two APIs simultaneously and will store all the matching properties in a single aggregated array. That aggregated array before returning will be set to Redis cache. Remember if the condition Redis hit does not exist, it does not undergo the Redis cached data condition, and it will be returning the aggregated data. So before showing you my live demonstration, I want to be showing you start scheduler file. This is the file which runs this function aggregating function every 30 minutes. So every 30 minutes it's going to be awaiting data and the tokens, this is the data basically which we need, and it's going to be setting in Redis cache and going to be making a connection with get.io. This is the socket server, which is going to be emitting the same events like from here, like tokens updated. And this is also going to be tokens updated. Yeah, tokens updated. And if the data is found, we will already return it in the form of get data. If not cached, then we're going to be setting it in Redis. Yeah, so basically this is the crux of the whole application. The rest of my files are this is the Redis file which I'll be using to create a Redis connection. So let us check. First, I'll be checking my Redis. It does not contain any key. Next, I'll be running this file with this TypeScript file. Yeah, see, so these are the two APIs. One is the CoinGecko Solana, and next is the DexScreener API. So the results of these API, we will compare every single coin which has more conditions. We are going to be grouping those conditions and displaying them singularly. You will see. So to check this API, this is the main route of my server. This. So these features also have implemented basically the sorting by sort order and limit function, which tells you how much to paginate. This is cursor pagination. This was new for me. And filter by time period. How much do we need to check it? So test this API. If we go to the original URL without any query param, so this will fetch us all the data, all the current data that we need. I'm going to be sending a request to this. Yeah, see, it took long, 1.272 seconds. The response time is too long because the data right now is not present in Redis. And after being hit, it will create a cache in Redis. See caching. And if I'll be checking keys for now, I think data should be cached and set in Redis. Aggregated local, which what this means is basically the key was created and set in Redis. And next time I send a request, I should be able to get the response in a very small duration of time. Why is it taking so much time? Oh no, I closed my server. So basically the cache was only for 30 seconds. So yeah, you can see from 180 milliseconds it goes to 6 milliseconds. This is how effective Redis is. And I've also deployed this on a live URL. This is the main service API URL, and this is our route. A route is where the functionality of how much to paginate. By the way, also this also works fine. Every filter works fine. If you want to filter by these properties, you can get that response as well. And if suppose if you want to put a limit to reduce the load on our API, then it will only display according to the limit displayed. And this is the main URL I created, and this is the route. So here you'll see all the data. You can hit on this site again, and it will display all the data fetched from Redis. And by the way, this will run every 30 minutes. So every 30 minutes, we'll be getting live update. We'll be getting live update from DexScreener and Gecko Solana APIs, and that API that information will be displayed over on the internet. We can create a front end for that as well. So this is basically how we are implementing the functionality of data aggregation. And as you can see on my GitHub README file, I have also created instructions on how to run this project locally. And I've also mentioned the name of the server, which is the live server, which can be used to create the front end of the application. Yeah, so thank you for giving me this opportunity to create a project. I learned a lot from this project, and it was a new experience for me, and I look forward to hearing from you. Thank you so much. Pardon my lack of fluency in speaking in the end. Thank you.